Welcome, everyone. It's a pleasure to have you with us today. I'm Leif Oppermann. I head the Mixed and Augmented Reality Solutions Group at Fraunhofer FIT and also co-head the Cooperation Systems Department. We are based in St. Augustin in Germany and are the former German National Research Center for IT. I also serve as the Vice President of the newly found Virtual Worlds Association, which you are free to join. I'm very honored to be an editorial board member of Empathic Computing. I'm delighted to welcome you to this webinar and to connect with colleagues and researchers joining us from all around the world. Let me begin by talking about the journal for a bit, and then we'll come to our speakers today. So the EC launched the webinar series to facilitate scholarly exchange and enhance the visibility of groundbreaking research, creating a platform for dialogue amongst leading researchers in the field. This is our third webinar so far. For those who would like to learn more about EC, please visit our journal website or feel free to contact us via email. Today, we are truly honored to welcome Dr. David Andreoletti and Professor Silvia Giordano from the University of Applied Sciences and Arts in southern Switzerland, SUPSI, leading experts in emotion recognition in immersive and virtual environments and privacy-preserving human-machine interaction, advancing adaptive and responsible technologies. This presentation was collaboratively prepared by Silvia and David and will be presented by David. Before I introduce them, I'd like to take a moment to briefly introduce Empathic Computing, EC, so that scholars who may not be familiar with our journal can get an initial understanding of it. Empathic Computing is an international gold open access journal launched in December 2024, dedicated to providing a high-quality academic platform for researchers worldwide. The journal adopts a rigorous single-blind peer review process to ensure fair and unbiased evaluation while encouraging constructive and detailed feedback from reviewers. With a target impact factor of 6, EC aims to become a leading journal in its field, advancing excellence and innovation in research on empathic and collaborative technologies. To foster academic exchange and attract high-quality submissions, EC has introduced an annual Best Paper Award to recognize outstanding scholarly contributions and will waive all article processing charges, APCs, until 2029. In addition, we provide multi-channel academic promotion for published works, and exceptional articles may be selected for customized academic presentations. In addition, feel free to scan the QR codes below to follow our journal updates. You may also take a screenshot to save them. Thank you. Let's take a look at the journal's aims and scope. Empathic Computing is a peer-reviewed open access journal published quarterly that explores technologies that foster empathy and shared understanding, including AR/VR, psychological sensing, and AI-driven emotion recognition. It aims to transform collaboration through natural interaction, implicit understanding, and experience capture sharing. The journal covers a wide range of subject areas, including but not limited to collaborative AR, VR, MR experiences using sensors for emotion recognition and sharing, capturing and sharing real environments, machine learning and AR methods for emotion recognition, novel collaboration interfaces, and so on. We welcome scholars from around the world to engage with the journal, submit their research, and contribute to advancing knowledge in these critical areas. For more details about our journal, you can scan the QR code labeled Journal Homepage. If you have a suitable article to submit or recommend, please feel free to contact us. We welcome your submissions. We would appreciate if you could recommend our journals to scholars who might be interested. I'm delighted to share that Volume 1, Issues 1 and Volume 1, Issues 2 are now published and available online, featuring a selection of excellent articles. Please feel free to and download. Empathic Computing is an international peer-reviewed journal with a distinguished editorial board. The journal is shared by Professor Mark Billinghurst, who holds joint apartments at the University of South Australia and the University of Auckland. His groundbreaking work on VR, AR, MR, HCI, cognitive neuroscience, and empathic computing has had a significant impact worldwide. Our editorial team includes 9 associate editors representing leading institutions worldwide. The journal also benefits from the expertise of 31 editorial board members and 9 youth editorial board members from renowned institutions, contributing to a diverse panel of 50 distinguished scholars across 23 countries worldwide. This international team is dedicated to maintaining the highest standards of academic excellence and ensuring that the journal remains at the forefront of empathic computing research. EC continues to expand its editorial team and welcomes outstanding scholars to join us in advancing this dynamic field. We currently have one special issue open for submission. The topic focuses on adaptive, empathic, interactive media for therapy, with a submission deadline for 5th of December this year. For details, please scan the QR code. If you're interested in contributing, please feel free to contact us via email for submission details. We are also recruiting guest editors. If you have a topic you find particularly relevant or forward-looking, feel free to get in touch with a proposal. All guest editors will benefit from the following. First, fair and standardized peer review processes with article processing charges fully waived. Second, the opportunity to host an online seminar on the special interest topic upon its completion. Third, a dedicated certificate recognizing your role as guest editor. Fifth, gain insight into the latest research developments in the field and engage in more academic research and exchange opportunities. And finally, opportunity to be recognized as an outstanding special issue. We look forward to working with you to advance the development of this field together. With that being said about the journal, let's now come to our talk today. And it's my pleasure to introduce our speaker, Dr. David Andreoletti. He holds a degree in telecommunication engineering and a PhD in information technology from Politecnico di Milano, where he specialized in privacy-preserving techniques and machine learning. He is currently a researcher at the Department of Innovative Technologies of the University of Applied Sciences and Arts of Southern Switzerland, SUPSI. His research lies at the intersection of artificial intelligence, effective computing, privacy, and human-machine interaction. He has worked on emotion recognition in immersive and industrial virtual environments, developing intelligent systems capable of detecting user states such as engagement, comfort, and frustration through multimodal signals. In parallel, his work also focuses on privacy-preserving machine learning, with a particular emphasis on secure and responsible computation in large language models. David, the floor is yours. I stop the sharing.
So today I'm going to present our work in affective computing in virtual reality that we have been doing during the past few years. And the title of the presentation is Emotion Recognition in Virtual Reality Toward Adaptive and Responsible Technologies. All the works that I'm going to present today have been doing in cooperation with Silvia Giordano, who is the professor of our group at SUPSI. So let me start with the outline. I will first of all introduce the topic of affective computing and virtual reality, and I will try to explain how they can be coupled together. In particular, because affective computing yields several challenges that VR can help to solve. So basically, our work is about integrating the two technologies in order to benefit from the strengths of virtual reality to solve the challenges brought about by affective computing. I will then present what we refer to as the virtual emotion recognition and elicitation loop that we see as a sort of mechanism, let's say, or paradigm that in our view is the correct way to integrate emotion recognition and emotion elicitation, that are the two main subfields of affective computing in virtual reality. And I will describe how we implemented this mechanism in several scenarios, and in particular in industrial manufacturing, product design, and virtual education. Then I will mention some privacy issues and ethical considerations that come from the use of affective computing systems. We will see that since they need to work on sensitive data, privacy protection becomes paramount. And then I will outline some of the feature research directions that I believe are really fit with the scope of the journal as introduced before. So first of all, affective computing is a field that studies how to build systems that can sense, interpret, and influence human emotions. And we can identify two main subfields, as mentioned before, emotion recognition and emotion elicitation, that you can see represented in the figures on the right. You can see that the two figures are in a way one the flipped version of the other. In fact, emotion recognition starts from the observations, the signals generated by a user, like his voice, his physiological signals, or any other signals, movements, depending on the context. And then there is the emotion recognition system that tries to infer, based on these signals, the emotion that this person is feeling. While for emotional elicitation is the other way around. We have a target emotion, like, I don't know, anger, and we try to induce this emotion by providing specific stimuli on the user. Then what is virtual reality is a 3D computer-generated environment that has a lot of very, very beautiful properties, like, for example, sense of presence, embodiment, very high realism, immersion, context, dynamic adaptability, and so on and so forth. So let's delve a bit deeper into the subfields, starting from into definition of this task. We can identify several building blocks, several phases that are common to all the emotion recognition systems. First of all, data collection. I'm trying to explain these phases because each phase raises a certain challenge that virtual reality can help to tackle. That's why I'm going at this level of detail. So for the data collection, basically data sets consist in observations, as I said before, paired with the corresponding emotional states. Of course, we need to induce these emotions on the participants that help to build the data set in order to collect them. Then, when we have collected the data, we do pre-processing that can be a traditional pre-processing based on noise reduction, feature engineering, multimodal integration. And then we train the machine learning model in a supervised learning manner to map the observation with the target, with the emotional target. And then we use the model typically as a classification as a regression, depending on how emotion is modeled, is represented, and then we measure its performance. For emotion elicitation, we start instead from a target emotion. We present stimuli like multimedia or interactive tasks that are designed to evoke that emotion in the user. And also here, emotion elicitation is widely used in psychology, in general affective computing, and in human-computer interaction. Also here, we have different phases. We have the data preparation with the selection and design of the stimuli, the elicitation, where these stimuli are presented in a controlled manner, and then we measure to which extent the target emotion has been actually induced. This is typically done through self-reports or through automatic annotation using emotion recognition systems. Now, what are the main challenges in affective computing? First of all, there is an intrinsic ambiguity in emotion recognition because, first of all, emotions, the boundaries between emotions is not very well defined. So it can be hard to distinguish between fear and anxiety sometimes. Also because emotions overlap, they are not really well separated. And then there are subjective factors. This makes it very hard to generalize the emotion recognition system. Then typically emotional elicitation methods are ineffective, and because it's hard to actually induce the target emotion. And this is the reason why many times the data sets that we use in emotion recognition have been collected with the help of actors that simulate the emotion. And this contributes to build emotion recognition systems that are in a way biased to a certain type of expression. Then we have the issue of data scarcity, because collecting data sets is costly. It is hard to recruit heterogeneous people. So it is hard also here to have data that help to build systems that generalize to unseen people. And these generate some cross challenges, like the fact that the emotional response is uncertain, the fact that emotion recognition models are typically ineffective, or not typically ineffective, but they face challenges like they hardly generalize to unseen subjects, for example. And in general, we have low quality data sets. These lead to the main problem. So affective computing systems have a limited effectiveness. So the main question is whether virtual reality can help to tackle these challenges. And the answer is yes, but VR also introduces new challenges. So, of course, the opportunities brought about by virtual reality for affective computing are more than the challenges, but we need to be aware also of those. And in the following slides, I will describe some of the opportunities and challenges for each of the set that I have shown before. I will eventually share the slides later, so I will not go into the details of all the opportunities due to time constraints. So we'll go to the opportunities that for me are the more relevant. First of all, virtual reality brings contextual grounding, meaning that with respect to traditional emotion recognition, here the users are in fact immersed in a scenario that brings a certain semantic. So this semantic, for example, what objects compose the environment or what are the behaviors of the user in this environment, can help to strengthen the emotion recognition. So if the semantic is in a way can be characterized as a sad semantic, then it is more likely that the user is perceiving sadness, is feeling sad. So the typical emotion recognition based on the signals generated by the person can be also coupled with this contextual information. Then we have the embodied interaction. So we can capture a continuous stream of data, of multimodal data that go from the posture, the gaze, the gesture, along with the interaction itself with the environment. So this brings richer emotional data. Then virtual reality is, of course, provided through the headset that is equipped with sensors, but it is possible to equip the user with additional sensors that are not cumbersome. They don't hinder the experience, so smartwatches can be used, for example. And this helps to bring many more data into the game. Bringing different information. Then personalized calibration. We said that each person expresses emotion according to his style. So the possibility to continuously track the behavior of the user in virtual reality, because typically the use of virtual reality comes across sessions, makes it possible or easier to build an emotion recognition system that is specific for that specific person. Then let's go to the challenges. The main challenge is that there is a dynamic emotional transitions. So with respect to the traditional case, where observations like facial expressions were labeled with a single static emotion, so the emotion was in a way standalone. Here we have a continuous interaction with the environment, so a stream also of emotions. And we don't only need to identify the emotion, but also to identify the transitions between them. This is very important for adaptive interfaces. So the same challenge can be in a way seen from a different perspective, and this is the perspective of the ground truth and labeling challenge. In fact, if we want to have if we want to label the emotional experience of a user, we have to do it in a continuous manner across the use of the VR. Then let's go to emotion elicitation. So first of all, we have a higher experimental control thanks to the immersivity. Thanks to the immersivity of the VR, we can tune also the intensity of the emotional stimuli that we are providing, and it is very easy to couple it to provide stimuli in different modalities altogether. Like for example, 3D objects or images or sounds, they are all compatible with the virtual reality experience. And they can also be paired with the interaction where the emotion elicitation stimuli is more intense. So by moving within the environment, the emotion elicitation changes, and this increases also the realism of the approach. And this brings to ecological validity. It is possible to elicit emotions in a simulated way as if we were in a real world, basically. Then also these bring challenges. For example, I spoke about the intensity of the stimuli, and the calibration of the intensity is something crucial because this can also have psychological implication. So imagine if you immerse a person into an environment that is meant to evoke fear or stress. Of course, the intensity needs to be calibrated for ethical reasons. Then let's go to the data collection. For the data collection, I see the main benefit is the continuous longitudinal tracking, because as I said, VR supports repeated sessions over time. So we can track the user and we can collect as many data as we want about the same user in a quicker way. So this makes the data collection more scalable compared to previous methods. Then, of course, also this brings some challenges. The main challenge for me is privacy, because as I will show in a slide later, the data that are collected are very sensitive. So physiological signals, for example, are extremely sensitive. So since virtual reality enables the collection of these signals in a continuous manner and a lot of this type of data, then we need to put in place effective data protection strategies. So now I come to what we call the VE loop, the virtual emotion elicitation recognition loop. We saw that VR is a very promising technology for affective computing because it improves emotion recognition through context multimodality and the other opportunities I showed, and also improve emotion elicitation through immersive and personalized environment. Now, in this figure, we see how we are putting together the two main modules of emotion recognition and emotion elicitation in virtual reality. So basically, the virtual reality environment can be seen as a platform for data collection that feeds the emotion recognition model. So the emotion recognition model outputs a certain affective state, the emotion perceived by the user according to the system. Now, based on this emotion that the user is feeling, and based on a target emotion that we want to induce, we can dynamically tune the emotion elicitation model that brings a modification to the dynamic. Might feel anxiety, for example. So the objective of this instrument is when the model feels anxiety, I mean, it senses anxiety, it tries to induce another state like calm, for example, that is more suitable for the learning process. And now I will show how we have applied these principles, this mechanism, into several fields, starting from industrial manufacturing. We have been doing 3 projects. They were V-Machina 1, 2, and 3 over 3 years. They've been founded by IIT Manufacturing, and co-founded by the European Union. And basically, the objective of these projects was to build digital twins for helping trainee learn how to use industrial machinery that were costly and also dangerous. So the idea was to make the training phase in virtual reality. And we developed a motion recognition system that automatically identified the level of frustrations that basic from body movements, and these act as a feedback for the trainer to adjust the training module accordingly in order to improve comfort, engagement, and the learning efficiency. The users of our systems have witnessed a strong benefit from this approach because, in fact, they could identify pain points that outside the virtual reality they couldn't really see. So in a very targeted way, we could identify which points in the training modules were causing troubles to the trainees. And the VE loop, in this sense, operates both in an offline and online modes. For the offline mode, the designers basically took the annotations from the emotion recognition module and modified the training modules for the following sessions. While online, basically there was this automatic system that recognized the emotion of the user, and whenever the level of frustration was above a certain threshold, the training module was repeated until the user felt comfortable in doing some actions. On a similar vein, we also applied this approach to product design in another project called VR for CAD, where basically the idea was to take CAD models and to build their equivalent in virtual reality in order to help practicing with the product itself before the product was actually manufactured. So we focus specifically in this project on the design of automotive batteries. And also here we had an emotion recognition module that basically annotated when there was discomfort because maybe it was problematic to fix some components of the battery. And this helped the designers to understand how to make the product more human-friendly in a way. And this very same approach we have argued in a position paper that can be applied to other product design domains. So the idea is that the users themselves can cooperate with the design of the product, so doing some pilot or test phase where they help through this implicit annotation from the emotion recognition systems, help the designers to understand where the products had to be modified and improved. Then let's go to the VE loop in education. There is a current European project called EC丨Learn, whose objective is to build human-centric VR applications for educations. So here basically we build what we call the Magic X room, that is a virtual reality room that we design for making the data collection more scalable. And we relied on the theory of flow. That is a theory followed also in education that basically correlates the skills of the student, the level of complexity of the task with the perceived emotion. So it is argued that when the skills match the difficulty of the task, the student enters in a state of flow where the learning is the most efficient one. While instead, if the level of complexity is higher than the skill, this yields frustration. While if the level of the skill is higher than the complexity of the task, boredom is induced. So basically, we use this correlation to have a control as a sort of automatic emotion elicitation, because the user, by simply doing some task where we controlled the complexity of the task, we could induce either boredom, frustration, or the state of flow. And this made the data collection more scalable. Then let me go toward the conclusions. I want to mention the privacy issue in effective computing. So basically, emotion recognition relies on very sensitive data, like physiological signals, facial expression, heart rate. These are all data that are deemed sensitive. So these make it crucial to devise privacy protection. So ideally, we would like to have an emotion recognition system that can work on signals without leaking sensitive information, but only retaining the signals needed for emotion recognition. In Europe, we have the AI Act that classifies emotion as a high-risk AI application. So its use is restricted in public schools, in workplaces, in public places. And in fact, because collecting and processing this type of data is very prone to misuse if not properly secured. But we have several technologies that offer promising solutions. I mean, they promise they represent a promising ground for building privacy preserving emotion recognition. And I'm listing the main ones. Homomorphic encryption probably is the most important because it allows to do computations and so to run machine learning models directly on encrypted signals. Then we have others like secure multi-party computation, differential privacy, where some noise is injected into the signals to destroy partially the information, federated learning, or synthetic data generation. We are specifically working on an homomorphic encryption system that will be used for emotion recognition and on synthetic data generation. And I will say something more in a few moments. Now, as a feature research direction, our overall goal is to build a privacy-aware and adaptive affective VR system. So in order to get there, we need to tackle three main challenges. The first concern privacy and ethics of emotions. So we are, as I said, we are developing a privacy-preserving emotion recognition system that can directly work on encrypted data while maintaining the model accuracy. Then the second challenge is the limited and costly data collection. Here we are working on a synthetic data with synthetic data generation systems that are specifically suited for the affective computing field. In fact, we are basically trying to mix styles between given a limited set of samples. We try to extract the style of each person and to infuse it into the other samples in order to create synthetic samples that carry a certain emotional content. And we have seen from our early results that in regimes of data scarcity, this is very helpful. So this type of synthetic data generation brings a lot of advantages in terms of emotion recognition accuracy. And then the last is the challenge is a lack of automatized closed loop adaptivity. So basically, so far, the adaptation of the VR was done through the human intervention. Our goal is to replace this human intervention with generative AI. So we would like that the VR system itself, the VR scenery itself, modifies itself through generative AI in order to induce a target emotion in the user. And in this context, we are working with a team of psychologists because our idea is to apply this approach to basically psychological therapy. So this concludes my presentation. I thank you for your attention.
Thanks, David. think a round of applause, at least on the emoji side here.
Thank
Okay,
you.
I would like to open the floor now to the questions and answers. I've got some slides here. Maybe you could unshare, and I can share this just to aid the discussion. And if there's any question, I think also Michelle just started asking for question. Put them in the chat box or raise your hand, please. Any questions? Who wants to go first? So I've got one. So you're building these system like the VEE loop that you just presented, and you raised the inherent risks and opportunities and so forth. So if we embed that into future mixed reality platforms, or future way of interactive computing in 3D, they will surely shape the way that we interact with the technology, how we learn and how we work and how we engage with the data that is surround us. So looking beyond all these immediate risks and limits like the privacy and the EU AI Act and stuff like that. So what kind of long-term societal shifts in the positive or in the negative could you foresee? I mean, you must have thought about it at some point, that we should be preparing for emotional adaptation when it becomes a core feature of immersive technologies. Do you know what I mean?
Yeah, for me, since I mean, emotions are very important in many respects. If I think about learning, emotions are extremely important, not only in that. So having reliable emotion recognition systems, of course, help. I think about, for example, the use of conversational agents. Conversational agents have these, I mean, they really cannot understand the emotion of the person they are interacting with, for example. So I see that provided that we can build responsible systems, and by responsible I mean mainly privacy preserving systems, I think that affective computing systems will shape the society in many respects and in a positive way, but provided that these challenges are solved.
Yeah. Okay. Yeah. Great. Thanks for that. We got a question in the meantime in the chat. Mark, do you want to ask that out loud, or should I read it out for you? Maybe I repeat the question for Mark. I think he's on a bad line at the moment. So he wrote it also in the chat. So he liked the presentation and is first asking about if you want to share these tools, if they are going to be available at some point, and also how many emotional states.
I can see the questions.
Okay.
So for the first, I'm not sure if we can share the tools because they are instrumentals for some project proposals that we have been writing at the moment. I need to ask Silvia, who is the leader of our group, because he's more knowledgeable on that. But I will maybe drop you an email, Mark. While for the emotional states, they were mainly we started with 6, but then we decided to go for 3 because we in the virtual reality setting, because we mainly work with body motion, and it was really hard to distinguish between more than 3 emotions simply relying on body motions. But in other projects that I didn't speak about here, outside virtual reality, I work on I work with emotion recognition with voice, and there we had like 7 or 8. The emotions were the neutral state, the frustration, and the happiness or comfort. I mean, because we selected these emotions because they were very much suited for for the projects, industrial manufacturing or product design, we didn't expect to generate joy, for example, but the main objective was to detect moment of comfort or discomfort.
Great. I'm looking for more questions, and you know, maybe people are thinking about it. Could you write the 3 emotions into the chat? I had some hard time understanding the first one. There was something in the line. Maybe other people had the same problem. If you just put the 3 emotions in the chat, and I ask if there's more questions here in the round. For the time being, don't have to. Oh yeah, great. Now it's clear for everyone. So I would say, if there's no more questions, I'd like to thank our speaker again, David, yeah, and also your colleague Sylvia, who was also a part of the team and preparing everything. And before we are closing, I'd like to emphasize for those who maybe arrived a bit later in the webinar that the Empathic Computing Journal is open access and no article processing charges until 2029. So submit plentiful, yeah. Thanks, everyone. And David, I'm looking forward to maybe meeting you at some point in the future, and maybe also consider joining the Virtual Worlds Association in Europe. Thanks, everyone. Have a great day.
Thank you. Have a great day. Bye.